I'm Niamh. I'm your privately with other partners, whether they're private partners or other government agencies across the world. And you're going to hear from 3 of those companies this morning. I have been involved in this Space Careers Roadshow for a number of years, and I've met some amazing companies and we've spoken to them. But most recently, I want to show you something that I attended at the European Space Agency. I'm the champion in education for them. There's 15 of us that kind of represent ESA. And so here's a video of when I was there, just to give you an idea of how many companies are working with the European Space Agency, contracted to provide maybe parts or do research or whatever it is. So this was the Space Industry Days, and it's where I met 2 of our speakers today, Aubrey from Ubotica and Emer from LEOS. Oh, can I have sound, please? Champion for education. I'm so proud to be here today. So I'm going to be wandering around. Look at these rooms here. These are B2B rooms, and then there's the conference hall and the exhibition room and the cloakroom. I put my coat away. So join me today. Setting up the camera.
Secure connectivity obviously being one of it, and AI and applications and services as an overriding theme.
My fellow ESA champions are here today.
So, by the way,
Is it lunchtime? So I'm in the, I guess this is the industry hall. There's lots of small businesses here, and they are associated in some shape or form with ESA. And it's incredible how many companies that are here. These are an Irish company, so yeah. So day 1 was great. Even met some Irish companies, Realtor and Unleash. Yeah, I'm heading now, and I'll be back tomorrow for more. So it was a 2-day event, and it was very well represented by Irish companies. This is just more footage of it. So you had talks going on all day, and that was hosted by an Irish lady called Ruth McAvinia, who now works at Science Foundation Ireland, but she worked in the communications department. And then there was like over, I can't even tell you how many companies there were, but they had these sessions here. They were called B2B, so business to business. We're doing business there, and it was all about promoting industry around the topic of space, working directly with the European Space Agency. And then this is the exhibition hall, and I'm just focusing in on LEOS, who you're going to meet shortly, and they were one of the companies that were there. Robotica were there, Realtor were there, and many, many more. So it's a really thriving sector, and for anybody who's interested in getting involved in space in any shape or form, whether it's in business or whether it's in the sciences or legal or human resources, in any shape or form, there are many careers, and as a member state of the European Space Agency, you are all available to do that. So I wanted to just give you context to what to expect today, and to make you understand this vast industry that is growing exponentially as we sit here even this morning. Okay, all right, without further ado, we've had the emergency exits. You now know who I am. You're going to see me throughout the morning as I speak with each of our three guests. And for now, to give context to it all, can we ask the manager of ESERO Ireland, that's the Education and Resource Office of ESA, Stephanie O'Neill, to come and tell us a little bit more. So welcome, Stephanie.
Thanks so much, Niamh, and thanks everybody, and thank you for coming out on this horribly wet morning, and especially thanks to your teachers for bringing you here this morning. So let me kick off. Am I working? I'm not. My slides have disappeared.
Let me see. I'll just see if I can.
There we go. There we go.
Brilliant.
Yeah. Okay, so as you know, this is a Science Week event. Science Week finished yesterday, but we tag on a little bit at the end. It's our third Space Careers Roadshow of the year. We do one for Engineers Week in March, for Space Week in October, and for Science Week in November. And we're so delighted to be back at face-to-face events. It's so nice to see your faces physically in the audience rather than looking at Zoom video screens, so you're very welcome here today. My clicker ain't working, lads.
Uh-oh, clicker.
Sorry about this. Oh, now it's working very quickly, sorry. Okay, so there we are. So this is just a quick breakdown of the day. So I'm going to give a quick introduction to the European Space Education Resource Office. And you might want to remember that because there might be a question about that later on. The European Space Education Resource Office. And then we'll have our three speakers, Aubrey from Ubotica, Emer from LIAS, and Des from Instatex. Then after that, we'll have a panel where we'll bring all the speakers up and you can ask your questions, and there will be a prize for the best question of the day. So we hope to get loads and loads of questions. We hope to run out of time with questions, so take notes as we go along. And there, as I said, there'll be a prize for the best question, so you need to listen to what's happening to get the question. We will, of course, have a break at some stage, I think, yes, at about 11:10, at which stage you can go outside. The speakers will be available to you then, so make sure to chat to them. Chat to all of us. If you have any questions to me about anything that's happening in the ESERO office, or what we have to offer, or what I'm going to share with you today, and certainly the speakers and Niamh, we're all available to you if you have any questions from today. Today should be a day of opportunity for you, so watch out. Niamh has already told us about the amazing opportunities coming into space here already and coming in the space sector. So this is a day about opportunities. Listen, ask as many questions as you can, and use the event to your own benefit. So I've already thanked you, but thanks sincerely to the speakers for giving of their time today. So Niamh has emceed many of these. She's a great friend of the ESERO office here in Ireland. And then we have Aubrey, Emer and Des. Again, they'll be speaking individually, and we'll have a panel at the end, and they will be available to you at the break as well. So just a little bit about the European Space Education Resource Office. It's a contract between ESA Education, the European Space Agency Education Office, and Science Foundation in Ireland. There's a network of 20 of these offices across Europe. And the contract between ESA is with a different organisation in each country. In Ireland, it's with Science Foundation Ireland, which is where I work. In other countries, it's with different organisations and different types of organisations. For example, in the UK, it's with the National STEM Centre in York. In the Netherlands, it's with the Science Museum in Amsterdam. So we all do the same things, but slightly differently. And that's the idea of the European Space Education Resource Office network, is that we take the resources and the projects that are developed by the European Space Agency, and we adapt them and make them appropriate for our own national countries. So we all do very similar things, but we do them slightly differently because we've all got different curricula and we've different systems in our own countries. So the ESA objectives, this is what my job is to do, is to enhance the literacy and competency of young people in STEM, in science, technology, engineering and maths. to motivate and enable young Europeans to pursue a career in the space sector, in STEM really, in the space sector. I mean, this is a space event, and of course we'll highlight opportunities across all different disciplines, but really what we're trying to do for a Science Week event especially is to promote careers in the STEM sector in the space domain, and to increase young people's awareness and knowledge of the importance of the space research and the impact that that has on applications in modern societies and economies. And we hope you'll be able to get that from hearing from people from our own space sector here in Ireland. Companies working in the space sector, companies with contracts from the European Space Agency. We hope that you'll see that there's great opportunities already here and coming in the sector. So I want to tell you a little bit about the ESA school projects. So again, these are run right across Europe, but my office runs them here in Ireland. I'll talk about CANSAT in a minute because I have a little video for you. That's the one that's most established here in Ireland. AstroPi is open at the moment and is run for 8-year-olds up to 19-year-olds, and that's a programming project. So students develop code, write code, and it's run on Raspberry Pi computers on the space station. And if you get through, your code is run on the space station, but you get a certificate which is date and time stamped for when your code was actually run on the space station. MoonCamp Challenge is new to Ireland, and that's using CAD, and it's about designing a habitat on the moon. And Climate Detectives then is reasonably new, but we've got involved over the last number of years in Ireland. We're running a pilot here at the moment with 20 schools, and this is really timely because, of course, COP27 is just over, and we really need to be aware of climate change and how we can help with that. But Climate Detectives allows students to come up with a problem, a local climate problem, and they've got to use data to either confirm or deny that there is this problem. And they've really got to use the scientific method. So this is a great project for transition year as students are progressing to senior cycle, because we know with change in the curricula that there's going to be a really, really strong focus on the scientific method and on developing that research question. So teachers, it's a really good project to get into it with TY for senior cycle students. CANSAT, of course, then, we're running this one in Ireland for 10 years. We're actively looking for teams at the moment. We just launched it during Science Week. We run it with 7 what used to be institutes of technology. They're now technological universities. This is where students from transition year and up get a kit, an Arduino kit. That's another thing for you to remember. They get an Arduino kit, and they have to build a satellite. And at regional competitions, the satellites are launched, usually using drones, and the satellites have to take temperature and pressure data from primary mission, and then the teams make a presentation to the panel of judges. Winners of the regional competitions go through to a national final, which will be held in May in Emo Court in Portlaoise, and the winners of the national final then go through to the European competition, which is held somewhere in Europe. We don't know yet where it will be next year. It was in Italy this year. So I'm going to show you just a short video just of students taking part in CANSAT at the national final last year.
5, 4, 3, 2, 1.
CANSAT because, well, at the beginning I wasn't very interested. Our teacher came to us about it and I was like, no, that's not for me. But then my friends were involved and they were like, you should really do this. And then I just looked into it and I was like, wow, that's actually a project that seems like worth investing time in.
I think it was a learning experience. I think we got a lot from it in the end. Like, the best way to describe it, our entire project was like a lesson in Murphy's Law. Not a single thing worked the first time. So I think it helped us with our problem solving and it helped with our teamwork.
I feel like it also, like, it was really nice seeing everything come together, and then at the end, and you see a parachute and you see sort of inside of a working can. It's really satisfying thing.
I'm not sure the sound was great on that, but you can see videos like that and that one on the ESERO website, ESERO.ie. But just to mention about those, I've talked about the 4 ESA projects for second level now, and there really are positive things to do, and they're extracurricular things, I know, but they really do develop students' 21st century skills. They help, of course, to develop technical skills and STEM skills, but they really are about developing the soft skills like working with teams, problem solving, analysis, communication. And they are the skills I think that employers are going to be looking for. We can all learn how to do things technically, but if you can't work on a team, really, in this day and age, it's really, you're starting on the back foot, I think it's fair to say. And I think that will probably come up in the discussions with the speakers today. So just to mention, the website is esero.ie, and all the projects are literally under the projects section. And the next thing I want to tell you about is the ESA resources, classroom resources. So there's quite a number of those. They're being developed all the time. They're resources to support the projects, but they're also resources for biology, chemistry, physics subjects as well. This is just a few of them. I took a screen grab of just a few of them. There's some for primary, some for secondary. This, you might want to remember this. The secondary colours are all coded in blue. The primary colours are coded in red. And again, the website again, and under teacher support, this is where we list CPD opportunities and development opportunities for teachers. So this bit of my presentation is for the teachers here today. 2 that are open at the moment. Well, actually, only one. The first one was just, we ran it last Thursday night, but these are coming all the time. So we ran an elective with the Junior Cycle for Teachers on Thursday evening, and it was about using images from the James Webb Space Telescope, which was launched only in December last year, with Irish company Realtra involved in developing the camera on the Ariane 5 rocket. And scientists from DIAS in Dublin working with the data that's coming from that now. And we're always developing workshops like that for teachers throughout the years. And then just to mention that ESA actually have an e-laboratory in Redu in Belgium, and the first 2 workshops for January 2023 have now been announced, one for primary and one for secondary, and you'll get all this on the ESERO website under teacher support. You might have remembered at the beginning of this, I told you about the ESA objectives, and the last one was highlighting the importance of space research and how that supports economies and modern societies. So I'm just going to finish off by showing this short video. It's about 4 minutes, and it's really just an introduction to the European Space Agency. I think that's really important that we know a little bit about the European Space Agency. I think we all know about NASA. We know less about the European Space Agency, and we, in Ireland, we are members of the European Space Agency. We pay into the European Space Agency, and they do amazing work. They have amazing missions, not least I mentioned the James Webb Space Telescope that just launched in December. So I'm just going to finish off by showing this short video. Thank you very much.
This is the European Space Agency, dedicated to the peaceful exploration and use of space for the benefit of humankind. Established in 1975, we work together with our 22 member states to push the frontiers of science and technology and promote economic growth in Europe. We have offices in 8 locations across Europe and 1 at Europe Spaceport in French Guiana, where we provide independent access to space for scientific and commercial missions. Exploring space is humankind's greatest adventure and one that we have been involved with for more than 40 years. ESA has the technology and expertise to keep Europe at the heart of the new age of space exploration. From low Earth orbit, we are working to bring humans back to the Moon and then onto Mars. By expanding the frontiers of knowledge, we are helping to answer the big questions about the universe. Space provides us with incredible opportunities to experiment and discover, yielding amazing new science. From Earth's neighbors to new worlds, we study stars, galaxies, and look for exoplanets. In addition to astronomy, planetary science, and astrophysics, ESA scientists work on growing food in space, searching for life on Mars, and understanding our own planet. From space, satellites are watching over Earth to monitor its health. Our satellites improve weather forecasts, observe the long-term effects of climate change, and contribute valuable knowledge to Earth science. The Sentinel satellites for the European Copernicus program provide vital information on our environment that can help improve our daily lives. Satellites also help you find where you are and get you where you want to go. We have developed Galileo, Europe's own global satellite system for navigating the globe. With over 20 satellites and a network of ground stations, Galileo provides precise global positioning information. Satellites are also connecting the world, making possible many of the technologies we use every day, like satellite TV and internet access. ESA is at the heart of Europe's satellite communications, developing new telecommunication systems and nurturing European innovation, bringing industry, science, and space technology together. In order to achieve all this, we need pioneering technologies that push the boundaries of the possible. ESA's world-class laboratories turn science into innovation, developing hardware and software for use in space and on the ground. Space technology gets rigorously tested to ensure it can withstand the harsh environment of space and the journey to get there. Traveling to space reliably is at the heart of ESA's vision for space transportation. We launch rockets that carry satellites into orbit and are constantly improving the design of our next generation of launchers, Ariane 6 and Vega C. These rockets and the reusable Space Rider will ensure that Europe continues to have autonomous and affordable access to space. Once in space, mission controllers are operating spacecraft around the clock to watch our planet, study the universe, and explore the solar system. We've flown more than 80 missions, including Rosetta, which landed Philae on Comet 67P, and Huygens, which touched down on Saturn's moon. We operate a worldwide network of ground stations to keep in contact with missions anywhere. ESA is dedicated to making space safer. Our teams help spacecraft to avoid collisions with space debris, and we are developing new techniques to deorbit dead satellites. We bring high-tech telescopes to scan the night sky for asteroids and missions to monitor our sun. With these technologies, early warnings can be delivered about potential asteroid impacts or hazardous solar activity that can affect infrastructure on Earth. ESA's diverse activities are all part of a clear vision for Europe in space. Space is the future, and through ESA, we are all part of it. This is ESA.
Yeah. Thank you very much. And thank you very much, Stephanie, for giving context to that. So yes, this morning is all about finding out more about how those of you that are interested in the room, how you can have a career in space. And we're particularly focusing on Ireland's involvement in that. And just to give a context, this morning in Paris, as we speak, the European Space Agency meets all the heads of state from the different countries in what's known as the ministerial. And every country pitches what science experiments, what programs they want to focus on in the next 2 to 3 years. And because it's made up of 23 member states, everyone votes together on where they go forward, and that's happening this morning. And then on Wednesday, they are announcing the next cohort of astronauts that will be selected. And from that, 4 to 6 full-time astronauts will be selected, as well as a backup supply of what they call reserve astronauts. And they said they'll have space for up to 20 of those, and those reserve astronauts will be involved in just one mission. And in that, they said that they were going to focus specifically on equality across gender, but also about representing the smaller member states, which is us. So there could be our first ever Irish astronaut going to be announced on Wednesday. So keep an eye on the papers for that, and hopefully we will. And that might inspire you to see yourselves more as having a future in the space sector, whether in industry or directly at the agency. Okay, that's just to give you context. As I say, we are all like mad into space, so please feel free to ask us anything as we rove around during the break. There's also a panel session after we hear from each of our three speakers shortly, and we want to hear from you. We want to hear your questions, and there is actually a prize for the best question, and it's a really good prize. I'm going to get Danielle to come out and tell us a little bit about that as we get to that section. All right, end of housekeeping. Let's meet our first speaker. I met Aubrey. Aubrey is one of the founders of a company called Ubotica, which specialises in artificial intelligence in the space sector and other applications. And I met Aubrey at that Industry Space Days, and they had just won an award. So hopefully Aubrey will tell us a little bit more. So can you please welcome to the stage Dr. Aubrey Dunn. Hello. How are you? Take a seat. Take a seat. Here's your clicker, in case you need it.
Lovely, thank you.
So how are you, Aubrey?
I'm good, delighted to be here.
This is familiar territory for you, isn't it?
It is, yes. Yeah, I spent, I think, 10 years in DCU between studies, postgraduate and undergraduate, so I'm familiar with the campus. Been a while since I was back, but nice to see it's growing.
And the campus helped you in your current business as well, didn't it? You're stationed just down the road.
Absolutely, yeah. So our office is in Glasnevin, a kilometre down the road, so I didn't venture too far from DCU as a spin-in.
All right, so let's find out about how, I mean, those things don't just happen overnight, Aubrey, right? So like, how did you always have an interest in space? That's the first thing to ask, I guess.
Well, I certainly always had an interest in science and technology,
yep.
And I guess as I went through secondary school, I chose my subjects in that regard, and I always had that strong interest in understanding how the world works, and then the opportunity to work in a space-rated project came along, and that was fantastic. And I can't say since I was 4, I can't say I was interested in space, but it's certainly it's the forefront of technology in many ways. To be able to put technology in space, as you know yourself, is incredibly difficult, and so it's a real challenging domain, especially for technologists. So it's fantastic.
So will you tell us about Ubotica, and then maybe we'll go back and try and fill in the blanks of how you got from being one of the founders of Ubotica to your school days. So tell us more about what Ubotica does.
Sure. So Ubotica, as we say, we add the smarts to smart satellites. So we develop artificial intelligence hardware and software to be able to deploy AI in the space sector, particularly on satellite. We would employ a lot of software engineers. A lot of our effort is software development. And what we do is enable decisions to be made on satellite rather than on the ground. So this is really important. Primarily because space, if you like, has a data problem. That if we think of Earth observation satellites, so satellites that are imaging the Earth, they're constantly capturing images of the ground as they overfly, and at the moment they are capturing more data than can be sent down to the ground. So in other words, the ability to capture data is actually much greater and growing faster than the ability to downlink that data, to get that data transmitted to the ground. So in order to help with that problem, we help people to process the data on satellite and only downlink the relevant parts of that data. So it's helping to solve that data problem.
So basically, your intelligence, it's able to determine what's an image worth downloading and what's an image like you're going to go, that's garbage, just move it on. Yeah,
I mean, the most obvious one is cloud detection. So a lot of Earth observation missions, they would have visible spectrum cameras or sensors, so they can't see through cloud. So if they are imaging over Ireland on a day like today, they're not going to see it out of the ground. And at the moment, what typically happens is the data gets sent down to the ground anyway, and that costs time and effort and power and money. And then the images on the ground are just thrown away because they don't have any valuable data. So if you can filter them on the satellite and say, okay, if it's cloudy, we determine that on the satellite and we don't downlink it. We don't spend the time and effort and power to get it down to the ground.
And was it difficult for you to get that contract with ESA? How did that come about?
I mean, I guess it's a long story, but we ultimately we were contacted by ESA as in the company I previously worked in Movidius, based in Dublin, and they were interested in the silicon device, the chip, the computer chip that this company Movidius was developing. So it's a really small chip, about 1 square centimetre in size, and it's a really good AI processor, as in it's very low power. It consumes a lot, very low power. So ESA were interested in understanding could they deploy this on a satellite, and so they came to Movidius, and as it happened, Movidius weren't in a position to help them with that. So I finished in Movidius and co-founded Ubotica, and we tried to solve this problem for them, to take this small silicon chip and understand was it suitable for deploying on satellite in space. And we went through a series of tests. I can show some slides in a second of what we did to be able to deploy this in space.
Can we line up Aubrey's slides? I don't know if we have them loaded up for you. Just give us a second there.
Perfect.
Okay, we're working on it. That's fine. We're working on it at the moment.
So, I can keep talking anyway.
Yeah, keep talking, yeah. What's it like to... So had you set up a business before? Was that all new to you as well?
Yeah, so when I finished my my studies here in DCU, I did a postdoc for, I think, 2 years and worked on some really interesting technology around image correction, so removing distortion from images. And as a result of that work, we spun out a company. Myself and my colleague spun out had a startup basically that was based actually here on the campus, and looking at commercializing, opportunities to commercialize that technology. And during the course of that, I guess, several years, we got great support from Enterprise Ireland. I ended up doing a great course on entrepreneurship with Enterprise Ireland called the New Frontiers program. And that really, I guess, spiked my interest in the startup scene. And really the interest is, or what appealed to me was that it was the opportunity to really do something that I enjoyed, but also that I could see as being relevant and having commercial value, and being valuable to someone else and solving people's problems. But being given a chance to direct my own work was really exciting.
And we met at the Industry Space Days, and I met you, I was introduced to you by some of the people from Roadshow, that you had won an award the night before. So what did you win? And congratulations, by the way. What did you win?
So we won the 2021 ESA Team Achievement Award. So this is an award given out every year to the best team project within the European Space Agency. And all of these team projects are obviously collaborative. So we were on a project called FESAT-1, or rather a satellite we developed or helped to develop called FESAT-1, so an ESA satellite, a small CubeSat. And this was ultimately demonstrated the very first AI inference, so use of AI on a CubeSat ever in space. And so it was, as I say, a collaborative effort. There was people from Italy, from Slovenia, from the Netherlands, from Ireland, and obviously from ESA itself. And in a very short space of time, we put this mission together, flew it, and successfully demonstrated AI in orbit. So we were nicely awarded for this award, 4 weeks ago at this stage.
That's fantastic. Well done, Aubrey. That's brilliant. And of course, the CanSat competition is like a CubeSat. So if they were to get involved in the CanSat competition, they'd understand a little bit more about what's involved in deploying that kind of CubeSat. So while we wait for your slides, let's talk about you then. So what subjects did you like in school?
I mean, I always had an interest in the technology side, so I did physics, chemistry, tech drawing, and applied maths on the sort of technology side. I love them all. I thought applied maths was particularly interesting and relevant, and because it has that word applied in it, right? That means a lot.
Problem solving.
It is. It's about problem solving. It's a little bit less abstract than some of the other subjects. And was probably the subject that I benefited most from when I went into college, because, as you say, it's about real-world problems. It's not a simple solving equation. Exactly. It's much more how can you apply.
And why were you good at maths? Who helped you be good? Because obviously, like the subjects you just said there, I think you have to have a comfort around maths, I think, to be happy around applied maths. So who gave you that confidence around maths?
Well, I mean, some of it was at home. I mean, we were always, as children, my parents would bring us to plenty of museums and technology fairs. That interest was always there. My father was an engineer, or is an engineer. So it came from that as well. And I guess I had an aptitude for it as well, which makes it a bit easier. But I enjoyed it. And at the end of the day, maths, is the language of engineering. I'm an engineer, so
of course.
you have to have some liking for it, I think, to really follow this career.
And so then, how did you know what to study then? So did you know I'm definitely going to do engineering? Were you one of those people that knew?
I guess from pretty early on, yes.
Yeah.
I mean, I certainly chose all my subjects thinking about, having a career in technology, or science or technology for sure.
Yeah.
But again, also because I enjoyed it, right? I had some passion for it. I chose the subjects that I enjoyed and that I could see me using in the future. And I think all four that I chose, those kind of science bent or technology ones, have been really relevant.
And you did a particularly interesting. I'd love to have done your degree. What was which was your primary degree?
Yeah, I did mechatronic engineering or mechatronics. So I did that on the campus here. So it's sort
like
of
robots and stuff, or what?
Yeah, it's a combination of electronic control, computers, and mechanics. So they call it to develop intelligent machine systems is the way they describe the subject, which is true, right? It's about building machines that have some level of intelligence or some level of reactivity that are able to be maybe autonomous in some way. So it is kind of robotics, effectively. It was a great subject, and what was really interesting was, early on in our degree course, I think in first year, actually, the very first semester of first year, we had this really cool subject called Integrated Studies, where we were literally given different devices, and we had to take them apart, write about them, and put them back together again.
Cool.
So, from vacuum cleaners to PlayStations to washing machines. And it was really good because it's really hands-on.
Yeah.
And sometimes the best way to learn, especially on the engineering side, how something works is to take it apart.
Yeah, take it apart.
Now, we didn't have to turn them back on again afterwards. So I never checked that it actually worked afterwards.
It doesn't matter. You learn from it. And what subjects then, if for that degree, and actually just in your job now, that you studied are still valuable to you? What subjects worked best for you?
So definitely maths, right?
Maths, yeah.
I mean,
maths.
you have to be able to look at equations and not be scared. You have to be able to understand that sometimes maths is the most concise way of describing a concept. You have to be familiar with maths terminology and with applying equations as well, right? So a lot of the algorithms that we would deal with are, first and foremost, it's a series of equations.
Yeah.
And a lot of our software engineers, for example, they would take a set of equations or an algorithm, and their job would be to actually write the code to deploy that, and obviously to test it and verify and validate, etc. So maths is a huge one. Physics as well. I mean, understanding the world around you is really important because you have to understand how, as an engineer, when you build a solution, well, how does it fit into the bigger picture, fit into the real world? And particularly for space, the physics side is really important.
Yeah, you have to learn the laws of nature, basically, don't you?
Exactly,
you really have to understand them.
Yeah.
And what's the coolest thing about what you do, Aubrey?
I mean, the coolest thing is putting something you design into space, right? To go from designing something to building it, so circuit boards, to testing, to having them in your hand, delivering them to ESA, and ultimately have them flying in space and operating in space and getting the results back down is really cool. So yeah, there's understanding what other people are doing in space as well, right? Because space is so complicated that no one person or no one company can do everything. And all the projects by definition are very collaborative. So you get to meet a lot of people, a lot of different walks of life who are contributing towards these space missions and everyone pulling together for one goal.
Yeah.
I mean, there's some companies we work with, and for 20 years they would be on one project. For 20 years their career is building towards launching a mission and seeing its success.
And what was it like the day of the launch then of your piece as part of the bigger project? What was that like for you? Where were you, and how nerve-wracking was that?
Yeah, no, it was definitely nervy. I mean, we had an unfortunate series of events where the particular satellite, the FESAT-1 satellite, was on the Vega 16 launch. So Vega being one of ESA's small launchers. And the previous launcher to ours had actually failed. So there was we were delayed because there was an investigation into the failure of the previous launch. So that pushed us to about March of 2020 scheduled. And of course, COVID came along. So we were delayed by a further 6 months because they weren't allowed to manage the launch. So it was in September 2020. We were due to launch, and I think we had maybe three different nights at 2 o'clock in the morning. We all got up remotely to watch the launch, and each of the times it was delayed. So we had high altitude winds. I mean, the most bizarre delay we had was one of the days it got delayed because there was a typhoon in South Korea, and one of the tracking stations that tracked the launch was in South Korea. So they couldn't the guys in South Korea couldn't go in to man the station. So our launch in French Guiana was delayed again. So eventually, anyway, it launched. So we all watched it remotely. I think it was about 2 in the morning, 2:15 in the morning. But yeah, really, really exciting and nervy. Those first, I don't know, 20, 25 seconds are very nervy. And even then, that's if you get over that, you're doing well, but there's a lot that can go wrong after that, right? And I believe not every satellite on our mission actually, or on our launch actually
Made it.
Made it, yeah.
Wow.
Yeah, so some were non-functional. But yeah, it was great. And it was great to hear back from ESA then, 2 days later, that contact had been achieved and that it was in orbit.
Fantastic. Congratulations on that. So for everybody listening today, how healthy or how much can you see coming down the line for the Irish space sector? What advice would you give to students who want to get
growing
involved?
all the time. You know, we ourselves, we deal with many Irish companies and collaboratively on ESA projects, as well as companies around the rest of Europe. When we started, I guess, engaging with ESA 2018 probably, so 4 years ago, we didn't really know a lot about working with ESA, and we didn't really know anyone else who was working with ESA. But it's one of those things that when you start working with them, and when you realise who else is also in similar boat in Ireland working with them, you realise how big the industry is, and it's growing very, very rapidly. And you know, thankfully the Irish government is behind it and increasing the budget, and you know that's paid back in terms of the jobs and the opportunities, I guess, that are provided to people in Ireland.
That's fantastic. And then lastly, what advice would you give to yourself at their stage? What advice would you, looking back?
Well, good question. I mean, first of all, definitely follow your passion. I think when you're choosing your subject, or when you're looking at your career, or when you're thinking about opportunities, you know, in secondary school and beyond, definitely follow your passion. I think it's really important to enjoy what you do. I'm not saying every day you get up at 9 o'clock in the morning, or 8 o'clock, or 7 o'clock, and you know, love going to work, but you have to have that pull, that motivation to turn up and work every day, and to do something that really you get a kick out of, that you find some achievement from. I mean, the other thing I suppose I would say is that, you know, looking back at it for myself, any hands-on experience you can get, any internships, any summer jobs, any working with anyone, particularly I think in science, technology and engineering, any opportunity to work with other people in the sector and with hardware is really, really valuable. So definitely summer jobs, internships, and it doesn't really matter if it's directly in the space that you want to, or in the air sector you want to work in. It's also just experiencing what it's like to work in a company, understanding, you know, process, procedure, documentation, and just getting some hands-on experience of how projects run, and that could be really valuable. We see that when we employ people, that people who have that level of experience, even if they're just straight out of undergraduate, they're much more employable, and you can get them started much faster.
Yeah, by having that experience. So that's great. Okay, maybe what we'll do is when we're doing the Q&A, if we get your slides to work, you can show us them. Oh, the slides are good now. Do you want to show us your slides? We have them around. Yeah, because we have time.
I'm going to have to go through these really quickly, but
but no, do please, because we have about 2 or 3 minutes. Do please.
Okay, so you asked example what we do. So here's just 3 images of the type of work that we do. So
look at
on the bottom left application, this is an application of ship detection from satellite. So you can see the green bounding boxes. This is where the image is captured on satellite, processed through an AI algorithm to detect all the vessels of the ships that are in the image, and then each vessel is detected, and that information is then shared to the ground.
Wow.
The top left is a hyperspectral image. So this is an image where there are 30, 50, even 100 different, if you like, color channels at different spectra that are captured. So it looks like it's the false color there indicates all the different channels that are captured, and this is really useful for flood detection and for agricultural
vegetation and stuff.
Vegetation, exactly, health. And the last one is the bottom right, as you look on it, which is fire detection. This is a really interesting one because being able to detect fires in real time is really important, right? So some of the larger fires, they burn about a football field every second. So the faster you can detect the fire and notify the authorities, the better. So the idea here is if you try to detect fire on satellite, if you get that information quickly on satellite, you can transmit just the location down, and it saves you having to transmit all of these images down, which have to be post-processed before the fire can be detected. So it's a speeding up of the notification or alerts.
Really important.
I'm going to skip some of these, but yeah, this is just one really interesting part, I guess, of our project. So I talked about it before, the FESAT-1 project, or satellite. So we had to take this chip you see in the bottom left, so it's about 1 square centimeter in size.
It's like tiny.
It's tiny. So we took something that's 1 square centimeter in size, and we went to the largest machine in the world, which is
the Large Hadron Collider.
The Large Hadron Collider, exactly. So this big ring you see up the top is 27 kilometers in diameter, in circumference. This is the Large Hadron Collider on the Swiss-French border. And you can see a smaller circle up the top left, which is the super proton synchrotron. So we spent 36 hours under the ground, under that smaller loop. You can see some of the pictures down the bottom there, testing that small little chip in an ion beam. So,
Nice.
and that allowed us to check that it was suitable for space flight, right? So ESA wouldn't allow us to fly it until we checked that it wasn't damaged by radiation, because there's radiation in space and electronics can be disrupted.
And this was your test for radiation?
This is our test for radiation.
Very
so
nice.
once this test passed, then we were able to integrate into our satellite. So this is the VSAT-1 satellite itself. So
this is the satellite that flew?
This is the one that flew, yeah. It's
wow.
about the size of a large cereal box,
Yeah.
6U, so it means it's 6 liters. So you can see some of the integration. The top left is the sensor itself, again, very, very small. What else do I have
And
here?
many hours go into putting those together, don't they, Aubrey? We've no idea.
Oh, yeah.
Yeah.
I mean, this satellite would have gone all over Europe for different integrations
different
and testing
pieces.
before it was shipped over to French Guiana.
So
for,
hours and hours and
for
hours of
launch.
work.
Yeah, here's the last, the integrations on the left-hand side. You see 53 different satellites integrated into that, what's called a dispenser. So somewhere in there is our satellite VSAT-1. The middle image is then when the payload bay covered by the fairing. So what's on the left is inside that white fairing, and then on the very right-hand side is the the fairing or the payload sitting on top of.
So
of
this
Vega.
is kind of like Amazon in a way, really, isn't it? You make an order and they pack their trolley full of all the stuff that they have to deploy, and then they pack it in, and the outer covering is called the fairing, which then goes on top of the rocket. And when the rocket launches, the rocket takes it to the edge of space, and then they open the fairing, and all these pieces, all these different projects get deployed. And as you say,
Yep.
some of them made it and some of them didn't, and thankfully yours did.
Yeah. I mean, I think most of them. This is just the launcher.
Oh,
which
wow.
will play, but it may not. But as you said, there were 53 satellites launched at one time. They pop out one after another, so they're all in slightly different orbits. And even that dispensing of the satellite is a really dangerous.
Yeah, I'd say that
and
took hours to put
difficult
together.
phase.
Can we play it?
Oh, it
we
does play.
can. Oh, great. Here we go. This is your launch of your satellite.
Yes.
5, 4,
So this is what you saw in the wee hours.
Yes. Yeah. 2 o'clock in the morning. We were
That's amazing,
crossing our
Aubrey.
fingers and everything else we had to cross.
It's fantastic.
And then it's over, of course, really quickly, right?
Yeah, exactly, in seconds. And then you don't know if it's going to be okay. So that flew from French Guiana, I mean, from Kourou, French Guiana.
Exactly. Yeah. So
it's well done.
Second last slide. So this is the final result. So after launch, it took about 20 days before we had our first result back. So what you see on the right here is the original image that was captured on the satellite.
Yeah.
On the left is the result of cloud detection using AI on our hardware.
That's very smart.
You can see one overlaid the other, so it correctly detected the clouds in this example. So this was the final image. So this is the award we received. Yeah. So they even put the image up the top left of the award, the cloud detection. So.
Oh yeah. Look at that.
That
The actual is in the. That's brilliant, Aubrey. And there's Joseph Ashbacher. So he's the Director General. So he signed it as well. That's amazing. Congratulations, Aubrey. It's great to have Irish AI in space as we speak. So we better keep going, and we'll have you back for the panel session. So if you have any questions for Aubrey, don't forget to ask him at the end. So for now, can we have a huge round of applause, please, for Dr. Aubrey Dunn. That was brilliant. Thank you so much.
Thank you very much.
Thank you, Aubrey. Okay, thank you.
Thanks.
So Aubrey's gonna take a seat for a bit. So we have time to hear from one other person, and then we're going to take a break, and you're going to be able to go out and stretch your legs and talk to us one-to-one if you want. So somebody else that I met at the Industry Space Days was one half of a new company called LEOS, which are all involved in acoustics, and she's going to talk to us this morning. So can you please welcome to the stage Emer O'Carroll. So Emer. Hello again.
Hi, Niamh.
Nice to see you
Good to see you again. How are you getting on? Good.
So, Emer, how are you?
Good.
It's really great to speak to you again, because I met you, as I say, at ESTEC, which is in the Netherlands, on the Industry Space Days. And tell us a little bit first about LEOS, and then we'll talk about yourself and Rona and the amazing story of how your company started in school.
Yeah, so what we do is all about noise and vibration, noise pollution. And we have created a new material called Sound Bounce, which reduces noise and vibration on Earth in here, like things like cars, planes, buildings, even things like washing machines. And now we're also working with the European Space Agency to try and look at how we can bring that into space and reduce noise and vibration in space as well.
That's fantastic. So you have some slides. Do you want to go through
I just have one slide. I'm very straightforward. Yeah.
Okay, so tell me, like, this is really interesting. Tell me how your company started, because it started in what year in secondary school?
I guess 6th year, but the kind of concept of the company, or our original product as well, which is a sound therapy for tinnitus, which is a ringing in the ears. So again, kind of under the umbrella of helping people who have noise damage hearing, whether that's helping it after they have the noise damage or preventing it in the case of our material solution. Rona is my best friend since we were 15, and we did Young Scientists together. So we actually did it in 5th year and then in 6th year. And in the physics section, we were always very interested in science, physics, kind of understanding the world around us, but also in music. And I used to play the drums in a dodgy indie band, and Rona, as my very diligent best friend, would attend all of our gigs. I think I even used to make her lift the drums in and out of the car at points, like a very good friend. But we had started to experience tinnitus, which is like a ringing in the ears that you get maybe after you've been to like a disco or a concert or something. And we were wondering, like, what is this? And can we get rid of it? Or, you know, what's going on? And we understood then through kind of researching it a little bit more that it is kind of damage to your hearing, and that there weren't really a lot of scientific treatments out there at the time, which had kind of an accessibility, both in terms of the price and the geography of where you could access it. So we designed a new kind of sound therapy, which you listen to now you listen to it via an app. Initially, I think we played it on like MP3 players when we were testing it as part of our Young Scientist, and we took that to the exhibition in 2009, and we got 2nd place overall.
Wow.
But more than that, on the final day, you're sort of down the back wall and people are, you know, the general public are coming, and we were just swamped with people who have either tinnitus themselves or some other kind of hearing damage themselves, or a loved one, a family member. And it just, the scale of the problem kind of really became clear to us at that point. So we wanted to try and continue to expand our research, really, but we fell into this kind of chasm where we were just about to finish secondary school, so there wasn't really anything else to do funding-wise there, and we weren't yet in university, so there also wasn't that sort of pool to access. And a very important character in our journey, John from the local enterprise office in Sligo, we went, you know, we were talking to all sorts of different people about how we could move forward with what we had done, and he was like, well, you know, this is a kind of a product, you could sell this and that could fund further development, further research, and kind of bring it further. And we'd never really thought of that, so we said, sure, why not, let's start a business. So we incorporated in 6th year, we incorporated in May, we sat the Leaving Cert in June, and then sort of foot to the floor and launched in August of that year as an online tinnitus sound therapy. I think the legislation for like health on apps hadn't even existed. It came in later that year, so it was very early in that regard, and there was a lot of kind of skepticism about it. But you know, now you can get it on your phone really easily, which is nice, and it's obviously a much more normal thing as well for people to access things like even like meditation apps and stuff online.
So just to recap, you were in the middle of your Leaving Cert and you set up a limited company together, yourself and Rona, two friends from school, off the back of the Young Scientists, because you realised that there was a need to do more research on why people get tinnitus and how you can help them better. So, so you didn't want to let the idea go, and you realised that if you could sell something, you could use that money to keep researching. How did you juggle the Leaving Cert with that? That's huge, Emer.
I mean, I wouldn't advise it. I don't think it was, in hindsight, very easy. Well, we kind of, you know, didn't do too much active on it on those last few months in the lead up to the Leaving Cert. So it was really afterwards then in the summer that we did a lot of work on it, and a lot of the kind of science part of it had been done already for the Young Scientist. But yeah, it definitely was a juggle. I I don't even remember how we did it, to be honest.
Yeah,
We were very young, very enthusiastic, you know.
And you've managed to continue ever since. It's been the same. Wow. And then tell us about this space aspect of this then. How does space get involved in this?
So a good bit down the line. So the second product that we created was after we launched the sound therapy, we could really see again online that a lot of the people that were coming to us, a lot of our customers had noise damaged hearing from being in very noisy workplaces, and they either didn't have hearing protection at all, or the hearing protection wasn't very good.
Okay.
So we started thinking, you know, again, thinking about that kind of medium space, there was materials that existed that weren't very good but were very cheap, and there was technologies that were coming onto the market like noise cancelling headphones that are still, even the cheap ones are very expensive, and they're not durable enough to give to, say, like a builder on a day like today. They'd be drowned out of it and stop working in 5 minutes. So Rona and I had gone on to study physics in university in the meantime. I went to the University of Edinburgh. Rona went to UCD, and you know, physics was a really big part of our lives, problem solving, and we started looking at the kind of energy and the systems that are in place with noise and vibration, and created a new material that could respond to those vibrations. So we initially were looking at hearing protection as kind of a market, and then as we took on some funding and we're growing our business, growing our team, we really found that the pull from the market was actually more so at the source of the noise. So companies that make cars, companies that make insulation for buildings, things like this, which are often the same companies that make hearing protection. But they wanted to try and block the noise at source because it's much easier to do that than try and do the sort of compliance, giving everyone headsets at the beginning, or at the end of the process, I should say. And it was through that we'd been also doing some work in aerospace, and it was then that we were kind of approached by Ariane and Ruag, which are kind of what are called primes in the ESA system, the kind of big companies at the top, and they have what's called FAP, F-A-P, or fairing acoustic protection that they use right up at the top of the nose cone of the launcher.
Like what we just saw.
Which you will have just seen, exactly. So you know exactly what I'm talking about now. And inside there they have things like satellites that a lot of our other speakers are working on, which are really delicate. You spent a lot of time, a lot of money putting them all together. And the last thing you want then to happen when you're sending them up is to have them damaged by noise and vibration. So the noise and vibration at the separation stage and the launch stage before that are both really, really, really intense. What they use right now is essentially like a mattress. It is about as thick as a mattress. They're about the size of mattresses, and they just stick them onto the side. It's quite basic, if we're being honest. But you know, it takes a long time to qualify something for space flight, so it's an okay solution, but what they really want to do now is expand the space available for payloads, so they need to reduce the thickness, and that's one of the things our material does very well. We do kind of low rumbling vibrations very well, and we do reduce thickness very well. So what we're trying to help them to do is bring kind of bigger and kind of more instrumentation up to space, but we're at quite an early stage of that. We're in we're going into our third year now of working with ESA. You know, it'll probably be another 7 before we're anywhere near on a launcher, but it's an exciting kind of project to be a part of.
That's amazing, Emer. And so you're helping ESA basically come up with a big problem for them, which is, you know, we saw Aubrey with they have to pack those satellites in, and there's more and more and more satellites being deployed, and that space is expensive, you know, and so you're looking at that mattress and you're thinking, we can do it thinner, we can do it more efficiently. So, you know, by the end of your research, you could be the main provider, and actually every rocket that deploys from the European Space Station may have your insulated material on board. So
that's the dream.
That's amazing. Another Irish, achievement. That's fantastic. And so we'll go back, because this is fantastic. But I guess for me, I'm always trying to figure out, how did you get to become the person you are? So in school, like, what kind of student were you? So Aubrey was obviously very good at, he was very confident around maths and applied maths. Were you a similar kind of creature, or what kind of person were you?
Yeah, no, I did like maths. I think I liked the fact that you could get an answer out of it, which was
Like
nice.
it was tangible.
Yeah, and then physics, obviously, because I went on to study physics. Physics was one of my kind of big passions in school. But I also did like history and French for the Leaving Cert, and I loved history. I mean, if Rona was here, she would tell you that I was a big nerd in school, and she's not wrong. But I would say, like, I've always been interested in a lot of different things and kind of how the world works from a lot of different angles, and kind of not just the sort of physics and math side of it, but also, you know, how are we the way we are today, and kind of how were things in the past and how could they be in the future, and things like that.
Was space something that you cared a lot about in school?
I mean, the honest answer is no. Like, science definitely, and kind of the more broad like understanding of the world, but I'd say my interest in science has actually developed more the more we've worked with ESA, and the more I've understood about what's going on, particularly in Ireland in the space sector. Like, I didn't know until a few years ago how kind of vast the space sector is here, and all of the different ways in which you could get engaged in it. Yeah. Although I guess through college as well, when I went to Edinburgh, they have quite a big astrophysics wing, and they have an observatory which was just up on the hill kind of behind our physics building. I didn't do astrophysics, but a lot of my friends did astrophysics, and some of my friends did things like astrobiology as well, which was just starting out in Edinburgh while I was there. So it began to pique my interest probably more so when I was in college, but I think when I was in school I kind of didn't think about it that much. But definitely had a big interest in science and the...
And where does that come? Like, because I think there are some people that are confident around science subjects, and then there are those that believe that science isn't for them. So what made you confident around science and maths and things? Was it in the home, or...?
It was probably a mix of things. So definitely home helped. We were always like making things and breaking things, be it forts or mechano or whatever. My dad's an engineer. My mum is very good at maths. So I probably was surrounded by that to some extent. And again, I guess that Aubrey mentioned going to museums and things. I hadn't thought about that, but I was definitely dragged through a lot of museums, which I now love going to museums. I don't know if I did when I was 7, but that was a part of it. But I think the other big part of it was really doing Young Scientist and doing kind of projects and things through transition year specifically, because for a long time I thought I was going to be a lawyer, and then thought I would maybe study history and politics for a while, and then when it came down to it I had to fill something in on the form, and I went, I'll do physics, which is a big shift, I think, at least on the face of it, but I was always interested in all of them, so sort of trying to figure out which one I would exactly go for. And what I thought would help later on in life, in I think the problem-solving aspect of physics, so beyond the kind of pure scientific aspect of it, the way that physics teaches you to think about the world and about very big problems, and taking the really big problems, breaking them down into small problems, solving all the small problems and putting it all back together again, is something that I do kind of in work, in business, in a way that has nothing to do with science often, but you know, frequently you're encountering big problems that you don't know how to solve, and you have to find a path to figuring it out, and that's the skill I think in physics that really tapped into what I wanted to be able to do as a younger person, a child. But it was through projects and extracurricular stuff, and having fun doing it. Like, that's how I met Rona. In transition year, one day we were doing Italian. I think prego remains the only word I remember in Italian. But she burst into the room, and she had been involved, or was about to get involved, in a project building a Lego robot. And the 4th member of their team dropped out. And Rona and I had only really met like a few months prior, but we got on, and she knew I was a big nerd. So she burst into the room and said, Miss, can I take Emer for a minute? And she pulled me out to the corridor. She's like, would you be on this robot team? I was like, I don't know. Like, I don't know anything about robots. I can't code. I'm not sure. And then she was like, look, the 4th person's dropped out. We're going to Dublin tomorrow, so we'll get the day off anyway. I was like, yeah, sure, it'll be a bit of crack. Rona's going, we'll have fun. But it was through that Rona and I discovered, I think kind of deepened our passion for science, which I think Rona had a little bit earlier than I did. But also that, you know, we work together really well, and that there was a lot more to science and STEM and engineering than just the stuff we were doing
in books,
in labs and in books. Because I think in kind of junior cert cycle I was less interested in science, and then kind of the leaving cert cycle it got a lot more interesting for me. But I think it was because I started to understand what more was out there, rather than just, you know, Bunsen burners.
And tell me, you know, it's yourself and Rona, which is great, and it always has been. That partnership's been a really important part of your company. So what's it like? You know, we have to ask. Women in the sciences or women in STEM or whatever acronym we prepare to use. So what has your experience been as two women? You know, showing us how it's done and holding your own in the space sector, in the Irish space sector, and also in science and STEM in general. What's that like?
Yeah, I think, you know, it's definitely gotten a lot better over the last 10 years. Definitely seeing way more women coming through now in science, engineering. What I'd like to see even more of now is more women in leadership roles. I think we're getting a lot in the earlier stages, and that's great, but, you know, we need to kind of follow through on that. It's a mixed bag. I mean, there's the advantage of, like, you always stick out. We go to a lot of kind of material science composites conventions, and there will be like 98 men in suits and just a pair of us. Yeah, but like you'll find us. You know, we're easily spotted then in a room like that. So there's an advantage in that way. But I think, you know, there have been problems with representation as well. It's really good to be able to see yourself in other leaders in whatever it is, material science, composites, whichever kind of wing of science you're in. And that, you know, that wasn't something that we saw when we were coming through. We're very stubborn though, so we just sort of beat our way through it, but it's something we're very passionate about, sort of doing things like this, and also kind of mentoring younger women in STEM and in business, to make sure that there are, you know, more of us, and that we're getting through, and that people are aware of the opportunities. A lot of it is about, you know, networking and who you know, and just having someone to say, you know, have you thought about trying this program, or you should talk to that person, they're actually really good in your area, or whatever. And I think historically women don't have that same network, or aren't plugged into that same network, so I think it's really important to try and kind of, to bring them into the existing ones, but also kind of build new networks in that too.
Yeah. And then, you know, where does your, I remember I asked you this before as well, like to be that young and to do those things, like where does that confidence come from, or that self-belief come from, or does it? Or what advice would you give around, like, just do it?
Yeah.
How do you do that?
I don't know, I guess in some ways it was always in us, but also I think Rona and I have been very lucky that we've always encouraged each other.
Yeah.
And you know, if one of us is having a bad day, we always say only one of us is allowed to have a bad day at a time, because then the other one will pull you back out of it, which has always been the case. And we've always been very good at solving problems together. So, you know, I don't know how anyone founds a business by themselves, to be honest. It seems so difficult to me. Because I think, you know, having a team, having a partnership, having a support network is really important. And the support to kind of be encouraged. And, you know, well, I've been very lucky that I've had that with my family. That's not true of everyone either. No. So, you know, that's only one place to get it from. And my friends, I was very supported as well at university, where they let me also take on some business courses and things as electives, which was very unorthodox for a physics student. They looked at me as if I had 7 heads, but they did let me do it. I had a bit of battling to do, but they did let me do it, and you know, being supported, I think, is very important in that. And yeah, I think just, you know, trusting that you'll figure it out. You don't have to be great at everything to start with. God knows I've made more mistakes than I could possibly list, but sort of having a little bit of courage to try it, even if you're just trying a sort of a smaller thing to start with. And I think that was the thing with us as well. You know, we started with a smaller project, and then did the next thing, and then the next thing, and the next thing. And I think if you look at, you know, the 2007, I guess, to now, it looks like a really big jump, but it's just been a lot of small steps, and a few steps back, and then some more steps forward. But just trying to, I guess, trust yourself and give yourself the space to get things wrong and then figure them out, and ask for help. That's a lot of it too, you know, having people to ask for help either in business, in life, in STEM, whatever that is.
Yeah. Do you have a slide? Do you want to share your slide? Or
That's
that is
it.
the slide. Oh, that's
Yeah,
great.
yeah.
Okay, so then the last question then is, as you say, you don't just suddenly get here from transition year or 6 years. So looking back, the same last question I asked Aubrey, what would you say to yourself now, looking back at that person when you were 16, 17?
Oh God.
What advice would you give, or what would you say to yourself?
I think I would invest in better skincare at an earlier age is step one.
I disagree, Emer, you look amazing.
I do now. It took work. So no, I think you know, trusting the people around you and being sure to ask for help when you need it, not being too proud about getting things wrong, which I think I can definitely do sometimes. You know, sort of having the humility to understand when you need help, and then having the, I guess, the grace and the good humor to have people around you then that you do have to ask for help. You know, your support network and your team, whoever is in your team, is the biggest part of your success, I think, in a lot of ways. So just making sure you've got great people around you, and kind of cultivating those relationships, be they friends, family, colleagues, and you know, being a kind person and a nice person to work with goes a long way on that too. So as I think the soft skills have come up a few times, but those are all the important ones, really. I think, you know, most people can learn how to do some physics and maths and chemistry, whatever it is, but you know, communicating well, being sound, being able to work in a team, that's the hard stuff, and that's you know, what we look at.
That's the glue. That's the glue.
It is, yeah. That's what we look at when we're hiring people, more so than their technical skills. So
Can you get on with that person?
Yeah, and that's always been the critical thing for me throughout my career. You know, getting along with people, building teams, working within teams, collaborating with people who maybe I have very little in common with, but you know, you can find something somewhere to get along.
Lovely. Thanks very much, Emer, for
Niamh.
sharing your story. So that was Emer from Leah. Thank you. That was great, Emer. Thank you.
Thank you.
So there's we're going to take a short break, but just to remind you, there is a Cahoots coming up, and I hope you've been listening to the last two speakers, because the questions have been based on what we've just spoken about. We're going to take a break for 30 minutes. Come back and we'll have our final speaker. So I hope you enjoyed it. 1, 2. Can you hear me? Can you hear me? Oh yeah, we're back. Yeah, we're going to start back in about a minute. People are coming back into the room. I'm just conscious of time, so we're going to start back in about a minute. I hope you're enjoying it so far. Don't forget, there are prizes for best question, and I will be showing you the prize shortly. It's a really good prize. So we're starting back in a minute. So get comfy. All right, welcome back. Welcome back, everybody. I hope you had a good break there. We're going to keep motoring along, if that's okay, because we are still keen to finish on time, even though we started late on our break. So you're very welcome back. For those of you who've joined late, I'm Niamh. I'm hosting this amazing Space Careers Roadshow, which is created by ESERO Ireland in partnership with Blackrock Castle Observatory, who are hosting this amazing event this morning and always do a super job, and it's always a pleasure to work with this team. So before we hear from our third and last speaker, I just want to remind you that shortly, after we hear from Des, who will be speaking with me shortly, we have a panel session where you get to ask questions. And there's always an amazing prize for best question. And there's also a prize for the Kahoot, which we run afterwards. So I'm going to ask Danielle from Blackrock Castle Observatory, who puts the prizes together, to tell us what are the prizes for the Kahoots winner and what is the prize for the winner of the best question. Danielle, where are you? You're here. Come on. Come up here and show us. She's amazing, Danielle. Okay. Thank you. Danielle.
Hello everyone, thanks for joining us today for the Space Careers Roadshow for Science Week. We're all very happy to have you here. So Niamh was explaining the Kahoot quiz, and the winner of that will be winning this beautiful ESA hat, which is very fashionable and goes
very
with
nice.
lots of outfits.
A beanie.
And the winner, the big winner for the best question at the very end of the show, will be getting an ESA NASA prize pack here, which includes the bag.
What's in the bag,
We've got
Danielle?
lots of goodies in the bag.
What's in the bag?
In case you get thirsty, we've got a water bottle from Blackrock Castle Observatory. Very good, very good. And notebook, because we know you've got to take a lot of notes in school, so that's good. Yeah.
I'll get that. You can have it. I'll get that.
And we know that school can get a little stressful, so we've got you a space suit. An astronaut. And to complete your space look, we have an ESA exoplanetary.
Thank you, that's brilliant. That's good. That's well worth. So get your thinking caps on. There's a mission patch in there and everything. Thank you so much, Danielle. Round of applause for Danielle. Thank you, Danielle. Okay. So let's keep going. Let's hear from our last speaker. And I'm going to ask Des Gleeson to join us. So he's the CEO and co-founder of a company called Insatex. So welcome, Des, please. Hi. How are you?
How are you? Good to see you.
Good. Sit down. So, Des, what is Insatex?
Insatex is a company that was founded maybe 2 years ago, just over 2 years ago, that's involved in data security, storing your data, big companies' data, finance, government's data in hyper-secure locations where it can't be hacked. pretty much. And we are using space and satellites and photonics as a network to transport that data from a terrestrial setting here on Earth, from your computer, in a small constellation, LEO, low Earth orbiting satellites, to a hypersecure destination and back as you need your information, your valuable information.
Because cybersecurity is a big deal. As you just mentioned there when we were on the break, you know, Black Friday is coming, and that's a particular spike in scammers and stuff, isn't it?
Cybersecurity is a huge issue. And with the growth of AI, artificial intelligence, and hackers are militarizing that now, everyone in the cybersecurity industry is very worried about the future of being able to protect valuable data. The suggestion or the estimate is by 2025, every minute the global economy will be hit for 20 million.
What?
Every minute, 20 million. From out of our pockets, out of, you know, large companies is what they're aiming for, but it's a danger. So we're one of many different initiatives that are trying to solve that, and what we're looking at is the storage, where that data is kept.
To keep it safe.
Keep it safe, and hyper-secure to and from the customer. And we're using best of breed in cybersecurity. We're using companies that would traditionally work with the militaries within Europe. We have our satellite platforms, we have our all our primes in place. And they're designed and, you know, basically built.
What's really interesting about what you're talking about is that you're using space for business, but you're not necessarily like working within the ESA system. Tell us a little bit more, because it's very different, and I would say the pace is much quicker and it's more business focused, right?
When we started this, like, space is fascinating. There's so much about space that even the greatest minds can't get their understand around it. But when you bring it back to the commercial world where we are, it's incredible what's going on. But we're not working with ESA, but ESA know about us. We've been interviewed, we've met them all and stuff. We're pure commercial, and we're using we're using companies commercially. 5, 6, 7 years ago, governments and military ran the space industry. Now they're relying a lot more on commercial companies. There's some incredible companies in Ireland that we use the expression, you know, what's cutting edge technology, but there are some companies in Ireland that are actually cutting that edge. Literally winning all the top awards to work and design, particularly in photonic communications.
Wow, fantastic.
And they're our partners. But,
and you were saying there's a massive shortage. There's a dire need for people to get involved.
One thing we come across, I don't come from an engineering background. I wasn't the brightest in school, but I put my head down. I fell into the space industry, or to use the space industry, and created, with my co-founder Colin Eccles, we built an incredible team around us. So you don't have to be an engineer. There's so much to offer in the space industry. And one of the barriers to entry when you're trying to work with companies in space, and there's a difference between aerospace and space, is they don't have people. They need people. They're growing so quickly. 3 years ago, 3 years ago, you could find a lot of scientific stuff online. That's all disappeared now. Okay, so it was very easy to research the space industry and meet people. Now it's very commercial.
And so, what kind of people are they looking for? Can you see, Des? All types.
All types. From obviously maths and engineering and computers is something that is very important to enter into a sort of industry like space or aerospace. But they're really, like, I don't have any of that backing. I wasn't great at maths in school. Geography and history, retention subjects were my best ones. But it's very open to talk to people in space. If you have a good idea, if you can evolve what's going on, bring something to it, you've got a position in the space industry. And I can't tell you how fascinating it is, and the whole big thing. A few things were mentioned earlier on. James Webb. When you leave here, when you get your phone, just look up James Webb and images. You'd be blown away. It was only launched, I think, a year ago, less than a year ago. CANSAT, the teachers here, get involved in CANSAT. One of my kids' schools was in CANSAT, and they did quite well, but it directly sent one of them into engineering, one of the kids on that
brilliant?
Team. The space industry, as an industry, is crying out for people to work with it. Like, if you even go to orbital mechanics, astrophysics, those people take years to create. And they need more.
Yeah, they do.
On that high end.
And so tell us, you mentioned briefly what you were like in school. I think it's really important. Not everybody is good at maths. Not everybody are, you know, are good at physics or whatever. I love talking to people who've come at this sector from, you know, a much different background. And so you're a finance guy, really, essentially. So what kind of person were you like in school, Des?
Economics. We all have different types of brains. Mine was retention brain. I was good at history, geography, English and stuff like that, but not great at maths at all. Didn't have a mathematical brain. But I worked hard and tried, so got to where I was going. Then I went and studied economics.
What was that like? What's it like studying
economics?
economics?
Yeah, it wasn't bad. It wasn't bad at all. sometimes there's phases in your life you've got to put your head down.
Yeah.
And that was just one of them, as much as you can.
Yeah.
And then it led me into sort of project management in a finance world, in a finance setting.
Yeah.
And then I started talking to data center company. At the same time, I was talking to satellite people on a totally different story. And I put two and two together with a co-founder, Colin. And when we created the idea and then created the business and the model, and we went out to the different people we needed, we were able to choose literally the top people in the space industry that are working with us now.
That's fantastic.
And, brilliant people.
Yeah. And so so were you always good at numbers and money? Like, because I think there's people who are innately, they have a great understanding of how business works and how to make a profit and how to think that way. Would you say that that's the kind of person you are?
Well, okay, I can't say I like problems, but I like solving problems.
Yeah, okay.
That's one thing. I was that kid that took apart clocks as well and tried to put them back together. But I probably wasn't successful, as I realised I probably shouldn't be an engineer. But anyway, but I had to go. Accountancy always scares people, and I know a few accountants, but once you actually get there, it's a much, much easier thing, and that's what a lot of people find in subjects.
Yeah.
Me personally, maths wasn't my strongest, but what is a smart thing to do is we got people around us that are great at what they need to be good at.
Yeah.
And that's team building to solve an issue, which we've pretty much done.
So what do you love most about what you do?
Meeting people.
Yeah.
Like entering into the space industry was a learning curve. It was like climbing a cliff. But all these different sorts of people that you come across when you're trying to do something, solve something, create something, is brilliant.
Yeah.
You know, not all the doors are open to you, but it's always good trying.
Yeah. And what's been the biggest challenge for you so far in getting this up and running, or just in working in your sector in general? What was the biggest challenge for you?
Biggest challenges are always, I suppose, people, like everything, you know, are always the biggest challenges. But in this sector, what we're talking about, it's the storage of data, okay? In a terrestrial, on Earth, what we're using a constellation of satellites. Breaking into that area and talking to those people from a commercial area, from a commercial place, wouldn't have been very easy 6-7 years ago, okay? But now it's become much more commercial. Like, we know companies where they're in competition with each other, but like the CEO of one has done the PhD, envisions the PhD for the other. It's quite a small, tight area. But it's fascinating. So the challenges was to get to a level of understanding we needed to get to, while we have teams that can far more sophisticated in what they need to know, and then step back.
Yeah.
And that's actually a challenge, to step back, because you have to let the space industry do what the space industry does.
Yeah, yeah. And how did you make that connection yourself? You were saying that you saw this, and then you realised that the two of them were together. Was it just talking to people, or how did that come?
Talking to a data centre company about issues. Cybersecurity has always been a huge problem, and sort of how can we actually do that better? Okay. And then I was chatting to a satellite company, totally different conversation, and then just pulled some people together, and we started to research the possibilities and realized this is possible. Then we started talking to we chose our satellite partners, our different ones, our space partners, and they all sat up and went, yeah, we're really willing to do this.
Wow, fantastic.
And it's been fascinating. But for everyone here, I can't explain how exciting the space industry is, and there's so many places. There's lots of careers you can follow. And while the room is big and there's lots to understand, within space, it is infinite. It's incredible. Yeah. And they do need people, and you don't need to be good communications, because they need that within the space industry as well, because they're, it's one of the needs they have.
Yeah. And what subjects did you do in school that you still, they're the ones that kind of have helped you in life all the way through?
That's a tricky one. Well, I love history, but how it's helped, I can't say. I like history, but the maths is something I would use a little bit now.
Yeah, of course.
Obviously, reading spreadsheets and all that sort of stuff.
Yeah, you need it, right?
I need all that, but so maths helps everywhere. Everywhere you go, you need a little bit of maths.
Yeah.
Like how you want to evolve those skills will come your way. But like we fell into the space industry.
Yes, you fell into space.
Fell into space, literally.
Do you have some slides that you want to share with us?
Well,
tell us a little bit more.
Just see.
Thank you.
Oh, we got here. This is just when Microsoft admitted their source code has been copied. Okay, you know how dangerous and how focused cyber criminals can be. Microsoft admit this. It's out there. And there's plenty. I think that's Homeland Security, which would be hugely protected, but hacked, and by a number of countries. Let me see now. All right, we're getting a line here. All right. This is just a chart. I think at the top there, they say by 2025, it's trillions a year it's going to cost in stolen data, in crime.
Oh my gosh.
It's growing. So even companies that have a small offer here, or that can solve something, there's a place for them.
Is data kind of becoming a new product? It's currency, isn't it? It is, it's currency.
If we know the HSE got hacked, and what happened, it was a different type of hacking. They didn't really steal data, they just froze the ability to use it, and then you got to pay them a ransom, and then they unfreeze, or hopefully unfreeze, your systems. Then, of course, there's other types of data, let's say pharma companies, to protect what their trials and what they're working on.
Yeah.
They really, really, really have to be super secure with that. Finance, anything.
It's fascinating. It's a fascinating and probably really important sector that's emerging.
It is, but... Oh, that's a satellite. That's a platform, and that's photonics. It's communicating with lasers. That's a company, it's one of our second primes called Mynaric.
Yeah.
And that's on a Triton.
Wow.
And that's a satellite. I'll just show you a satellite because they're brilliant. And James Webb, do look it up. That's called orbital mechanics. One of the trickiest things is how to fly satellites. You think it might be easy, you put them up and they just fly around. The Earth, the atmosphere, everything does something different all the time that changes it. And that's a skill in its own. Yeah. That's old mechanics.
Yeah.
And then I'm just going to give you again Insatix. That's the name of the company.
Very good. So what advice then would you give to our budding entrepreneurs in the audience?
Teachers do CANSAT. Go and look at the ESA website. The ESA website is a rabbit hole of information that you can get lost on. It's fascinating. I think a year or two ago they were asking any one of you could have put your hand up and joined their astronaut training course. That might still be going, I don't know. Any budding astronauts in the audience?
Many, I'd say. Many.
Really, don't ignore the space industry, because it's not going to stop growing. There is an Irish-American guy called Mike Morris, lovely guy, who is a very good architect. And somehow, if you talk to him, he's like, well, it just happened. He's now the lead in NASA for designing habitation on Mars.
Very good.
And he was just an architect.
Yeah.
So it's there.
There's a place for everyone.
Yeah.
all right. Okay, thanks, Des. Thanks very much, Des, for joining us.
Thank you.
So you stay there, because we're going to do the panel event. So now, thank you so much, Des. It's really interesting that, because we all understand the data. I mean, that's a massive thing for all of us as a threat. So what I'm going to do is I'm going to get Aubrey and Emer to join us on stage, and we're now going to have our question and answer, our panel event. So this is your chance to ask questions. You saw the amazing prize for best questions. We have people with roving mics. You see the people in blue? We have our volunteers there from Blackrock Castle Observatory. And there, oh, and also Stephanie, yes, as well, sorry, is going to be joining us for questions. So Stephanie is our manager of the Education and Resource Office for ESA. We have Aubrey from Ubotica, we have Emer from LIOS, and then we have Des from Insatex. So what questions do you have? You see the people in the blue jackets? They are all taking your questions, and they have mics. There's one over here and there's one over there. So hands up, anybody who'd like to. Oh, there's one at the very back. The very first person I saw with their hand in the air. But the very, very back row on the left, he's actually lit. That's why I could see him. And then, Francis, you can tell me how many we have left. I'm going to follow Francis's lead. So here we go. And don't forget to tell us your name.
Okay, so I'm Mark. And just my question, it's for anyone in the panel.
Yeah.
In a world where we're being told constantly, space is the future, that's where everything's headed, and we've got the biggest billionaires funding like programs to get people into space and potentially get people onto Mars, I wonder, could that be potentially detrimental to the climate change problem, that we're getting people funding that industry of getting people off the Earth instead of letting us live on Earth?
Yeah.
That's effectively the question.
Okay, that's very good. So space, is it a threat to climate change, or is it working with it or against it? Does anyone want to answer? Aubrey?
Well, I mean, just a quick example. I think solar panels are a really good example of where solar panels originated in space, in space technology. You know, it's a solution that was developed to enable satellites to have longer life in orbit. And that technology is filtered down, and nowadays we see solar panels on, you know, I think most of the new houses at this stage are mandated to have solar panels on them. So space technology, a lot of money is put into space technology development for some of the tasks that you're talking about, even for, you know, visiting other planets. But ultimately, a lot of that filters back down into real applications on Earth, and I think solar panels is a good one where it's helpful to the environment rather detrimental.
Yeah. Stephanie?
Yeah, just as well, I mean, we need to consider the Earth observation element. I know in this is ESA video, it talked about the Sentinel satellites. It's a suite of satellites that are constantly monitoring the Earth, and I know you touched on this in your presentation as well, Aubrey. So it's really important that we have those satellites, that they're monitoring the Earth and informing us of what's going on, and hopefully telling us in advance of potential climate change challenges.
And I'll jump in as well, because it's one of mine. Or do you want to? Were you going to answer something? Yeah. I think the space sector, like in terms of even launching, they're always looking for propellants that are more sustainable. So you even saw the launch last Tuesday night of Artemis. So the main tank of that was liquid oxygen and hydrogen. So the byproduct of that is obviously water. And I think sometimes on a deeper philosophical level, which is where I always come from with spaces, I think sometimes you have to step away in order to understand what you have. And I think a lot of astronauts will tell you that whenever they're orbiting Earth on the International Space Station, all they do on their break is look down at Earth. And so I think it's like every time you leave home, you appreciate your home when you've been away and you get to go back to it. So I would hope that a lot of the technologies that we develop in order to be able to survive in space with no oxygen, no water, no food, there's nothing stopping us bringing them back down to Earth to provide better filtration systems and recycling systems. And we can learn a lot about how to live better here on our planet when our own natural resources are taken away from us. It's a really good question. So another question then, do we have?
Yeah, we have a question from Jada.
Yeah.
Do I hold it or do you? Yeah, okay. My question is, when you were saying that the satellites are able to tell you different climate changes, like the weather on Earth, were there any significant changes during COVID-19 when people weren't really like out and about? Like, were there any significant changes in the weather or like atmosphere when everyone was like pretty much stuck inside?
I believe so. Does anyone want to answer? Anyone? Aubrey, would you?
I mean, I've definitely I've seen articles on exactly what you're talking about, where in 2020, in late 2020, where they looked at, I can't remember, was it carbon dioxide or methane in the environment over the large industrial cities in Europe, and they compared that to the year before, and they saw that it actually was reduced. So they get this information very, very quickly. And yes, you can see these trends, and these trends are obviously really important to understand when they're growing, obviously in terms of gases in the environment that are detrimental, but sometimes it actually goes the other way, and COVID-19 was an example of that, where there there was less of these dangerous gases in the environment over some of the industrial cities in Europe. So yes, they do track them, and there were some changes.
Thanks, Aubrey. Stephanie, did you want to say
I was just going to add to that, because ESA has this tool called the EO browser, the Earth Observation Browser, and there is an education module on that, and you can actually go in yourselves and have a look at the different gases, or there's different themes and different things that you can look at from the satellites, and you can actually look over a period of time, before 2020 and during 2020, for different gases. You can look at agriculture, you can look at air pollution. So you can actually go in and investigate that yourself, and you could do that as part of the Climate Detectives project. And on the Climate Detectives page, there's actually a mini case study around air pollution and to guide you how to actually find out that information.
Okay. All right, next question then. Yeah, if the people asking the question can stand up so we can see you. I'm sorry, I know it's embarrassing, but there you go.
My name is Ellen, and
Hello,
I actually
Ellen.
have 3 questions.
Ellen has 3 questions. Thank you, Ellen. Are they for general or for anyone in particular on the panel?
Just in general.
Okay.
The first one is, what percentage of the astronauts... You mentioned that there was going to be a talk on Wednesday about another project for going into space, and you mentioned that some of the astronauts might be Irish. Do you know how many of them, what percentage of them might be Irish?
Well, I think what you were talking about, so I said at the start of this event that on Wednesday we're waiting for an announcement for the new core of astronauts from the European Space Agency, and they've told us that they're going to have 4 to 6 full-time astronauts, so they're going to have a career at the European Space Agency over probably 20 years or so. And then they're going to have a para-astronaut, that's somebody that may on Earth have a disability in terms of some sort of limb malfunction, but in space that doesn't matter. And then they're going to have a reserve of maybe 10 to 20 people that are going to be taken on just for one mission. And they were saying that they are going to try and focus more on the smaller member states for that. And so from those 20, the opportunity for one of those to be Irish is certainly higher. And when we were looking at the figures, Stephanie, do you want to quote the figures for astronaut selection? There was in the last round that I heard, there was about I think there was 1,100 left, and 22 of them were Irish, and I think it was about at least 30% of those were women.
But just to put that into context, this started, what, a year and a half, 2 years
It started
ago?
May, the deadline was May 2021, and so for the last year
and
they
there
were
were
looking at
22,000 applications. So we've whittled that down now to the final announcement this week.
Yeah.
And we're hoping that there will be some Irish names on that.
It would be great. What's your next question, Ellen?
This one is... It's a bit silly, but I just thought of it when you mentioned it. Are there any protocols for if you actually find life on other planets? Is there anything put in place?
Anybody want to answer
that? Not that I'm aware of, but Voyager was launched many years ago. Maybe someone can help me with that. And on the side of it was golden discs, records of man, woman, and sounds of the planet Earth, and it was sent off. Now Voyager, I think, has left our galaxy now.
It's in interstellar space.
Yeah, and it took an amazing photograph, reverse, of Earth as it left our galaxy. It's one of the and it's still transmitting. Some people think it was a really good thing. It was a very famous film director that actually did I'm trying to remember him, Eyes Wide Open or Eyes Wide Shut. Stanley Kubrick did the music, etc. And that's been sent off, and some people think that's a really good thing. Some people think, well, if that lands on a planet where there might be the friendliest of life, it could be a bad thing, but it's happened.
Okay, and your other question, Ellen?
This one's kind of just for each person on the panel.
Okay.
But for each of you that are working on projects right now, where do you see those projects going in the next 5 years, and what do you hope for them?
Okay, we'll start with you, maybe, Emer.
Yeah, sure. So the project that we're working on at the moment is all through the Future Launchers Preparatory Programme, the FLPP. And we're kind of one part of that in the acoustic vibration side. So where we'd like to see that, really, I think in the next 5 years, is still all in qualification. So there's a lot of testing that has to happen for a new material to go to space, everything like vibration and shock, temperature testing, the pressure as well, because obviously the pressure changes a lot during flight. So I think in 5 years' time, if we were to get to the end, to the other side of the qualification testing for those materials, and then kind of be ready for being on the next launch then, that would be fantastic.
Yeah, thanks, Emer. What about you, Des?
No, nothing in that area right now.
Okay, all right, cool. Thank you. Aubrey?
Yeah, so as I described, we have an AI module on a CubeSat the first time there in 2020. So we actually have our own satellite with a partner going up at the end of next year, which we are hoping to, what we call an AI-centric satellite. So we're really putting AI at the heart of the satellite, designing the satellite around this capability of AI. The next step after that is to get it to a constellation. So not just one satellite, but multiple satellites. And ultimately to be able to think of a satellite in that constellation, or that constellation of satellites, as almost like an in-space computer that you can ask questions to rather than just receive dumb data from. So you can say, let me know if you see a forest fire. Let me know if you see more than 5 ships in Dublin Bay, whatever it is.
Brilliant.
And so it's bringing that cognition onto satellite.
Brilliant, brilliant. Okay, next questions. Who are you? If you stand up so we can see you. Oh, he's over there. Yeah, hi.
For the Instex, the CEO for the Instex, what do you think about the security system of today's age versus back like 10 years ago? Like cybersecurity versus 10 years ago?
It's advanced significantly, and there's a company actually based in Northern Ireland that has pretty much cracked, or close to cracking, quantum computing in a cyber-secure environment. And that's the next stage, but that also brings its own problem, because if people engage in quantum computing in a criminal manner, it's a problem. But it advances all the time, and cybersecurity is keeping up. The problem with cybersecurity is what is done to create the security is also used against the ability to secure.
So it must be really hard to keep one step ahead, isn't it?
You have to keep the step. And with AI, that's a big concern now. And then obviously quantum computing opens a completely different world to all of us, but on its own.
Thank you. Great question. Another question? Over here? Yeah, if you stand up. Yeah.
Hi, my name is Candice, and this question is for Emer. So you mentioned that back in near the end, towards the end of your secondary school years, you opened a business with your best friend Rona. I was wondering how you two decided to market your business, because back then, like you said, there was like a lot of skepticism around the topic.
Yeah, thank you. It's a great question. So we started, when we started in the summer of 2009, we had the great advantage of having kind of come from the BT Young Scientist, and we knew that that was a good story, and our marketing budget was the grand total of €0 at the time. So we had to kind of figure out what we could do for free, and at the time, I mean, social media was actually still just kind of taking off. Like, we had a Facebook account for a few months, but it was still quite quiet. So we actually did a lot of promotion through traditional media. And we did up, like, we just wrote it ourselves. We kind of looked at some examples online of press releases and kind of trying to figure out how to hook kind of either we did things through radio, through the newspaper, some TV as well. And a lot of it was just, you know, perseverance and sending a lot of emails and following up on them to different radio presenters and different newspapers, things like this, and then trying to see, you know, how much coverage we could get. So we did really well then in the first week that we launched the app, or the website, I should say. I think we were in, you know, 5 or 6 different newspapers around the country. We were on Jerry Ryan at the time, RIP, very sound man, Jerry Ryan. And I think we were on some other, like Nationwide or something as well. We just, you know, you have to find out what's unique about your story or your product and try and kind of pitch that to people, particularly, you know, when you don't have a lot of money to pay for advertising.
Yeah. Okay, very good. Another question? If you stand up, yeah, thank you.
I'm Caitlin, and I wanted to know if a satellite breaks or like crashes, can you fix it? or does this just stay there?
Yeah, that's a great question. That's a really good question. So if a satellite breaks, can you fix it?
Yeah, maybe I'll take that one. So, I mean, people are trying to do something called in-orbit servicing at the moment. So it's a concept still, it hasn't been proven, but basically where you have one satellite that will try to service satellites that are already in orbit. But typically, no is the answer. At the moment, no. And this is not uncommon, right? It often happens that some subsystem in a satellite develops a problem or breaks or is damaged by radiation, and often enough it's unrecoverable. Sometimes you can try doing software patches, but often it's not recoverable. But in the future, they hope to be able to service satellites in orbit. Yeah.
Okay.
Niamh, can I just add to that, because that's actually a really big problem. So if any of you brilliant minds in the audience can come up with a solution for this, it's a really big problem, the amount of space debris that's actually out there at the moment. And ESA and all the space agencies, of course, they're actively looking for solutions to this problem of space debris. So if you can think about that and come up with some solutions to help to fix that, that would be a great way forward for future careers.
Yeah. Next question. Where are we going? Where are we? I can't see. Oh yeah, you start. Yeah, hello.
Is this on?
Yeah.
My name is Varshini, and my question is for everyone, all of you. It's that living on Earth, we all see, like, everything we see now is considered normal. So for you guys working in space, when you see new discoveries and make new discoveries, is it overwhelming? Because what you see can be considered as fiction-like or phenomenal. Like, how would you feel every day knowing that, you know, these kind of things are going on outside of Earth?
So you're asking how we respond when we see these discoveries, like what Des mentioned with the James Webb and all these different things, how they affect us personally. Yeah. Okay, that's a great question. Okay, Stephanie, I might start with you.
Well, the James Webb is a great example, actually, and I mentioned that we did a workshop on Thursday evening last week for junior cycle science teachers. And Paddy Kavanagh from Dublin Institute of Advanced Studies actually took one of the images from only in the last few weeks from the James Webb Space Telescope and explained to us how they could be categorized and classified and the different colors and what that meant. And it really was an amazing image, but it was brilliant that he was able to make it into something that could be used in a junior cycle classroom. So for me, that's amazing, is to be able to take something amazing like that and make it relevant to the classroom of a 13-year-old, a 14-year-old, or a 15-year-old.
Yeah. What about you, Aubrey? What amazes you about all these discoveries?
I mean, continuously amazed for sure. What people can do in the space technology or in the space sector is really impressive. But I would almost look at it in a different way, which is what amazes me most is human ingenuity, that we can actually achieve what we achieve in space. I mean, thinking about even something like Voyager, 40, 50 years ago, it's incredible what was possible and what continues to be done today, and what we can put up there and help us to view our Earth in a different way. It's the human element that really I'm amazed by mostly.
Yeah. Emer?
Yeah, I think I kind of had the same reaction to your question. I think it's very inspiring, kind of what the product of collaboration can do, and what the product of, I think, like inter-country collaboration as well. ESA is a collection of, can't remember the exact number now off the top of my head, but a lot of countries around Europe and beyond. But also space in general. There's a lot of collaboration between NASA and ESA and the different space agencies all over the world. And the more that we do that kind of work together, you would hope the more that it's going to bring us forward as a kind of a global community in tackling things like climate change, like our first question mentioned.
And Des?
I agree with Aubrey. Human intervention and in space, it's fascinating. Nearly every couple of days you'll read something that's a bit mind-blowing. But space is so huge. There's generations and generations of exploration to be done. And it's a constant.
Yeah. Okay. Next question. Where are we? Yeah. Where is it? Oh yeah. Here. Yes. Hi.
Hi. My name's Senan, and I'm just curious. I think probably targeted towards you all, but about the exploitation of other planets. Obviously, in the far future, Earth is running out of a few essential resources, especially for phones. I've heard about one of the main ingredients for it is running out. I'm just wondering if something similar were to be found on another planet. would we be willing to take the risk to import it from that planet to here, and whether or not there'd be any moral concerns or concerns economically for it?
Right. So you're mentioning the topic, which is, I think it's called asteroid mining, really, isn't it? So it's about looking at other planets, not only not only planets, but asteroids and comets and all sorts of celestial objects to kind of take those minerals and bring them back to Earth. Yeah. Okay. What do we think about asteroid mining? I think it's an ethical and a moral question as much as a resource question. So
But one of the things, Niamh, that's really opening up at the moment is space law.
Space law.
It's a really opening area because if you do land on an asteroid or whatever, who actually owns it?
Yeah.
So there's a huge learning and a huge amount of research to be done around that, the law of landing on a comet or landing on an asteroid.
Yeah, it's an ethics thing as well. Anybody else want to?
Yeah, I don't think I have a kind of a final answer to it, but I think it's a really fascinating topic and something that we're going to have to grapple with very seriously. As you say, there's some very finite resources that we, at least today, really need. So I think it's all going to come down to the balance of, what can we replace that we already use through other things that we maybe have on Earth, or make more sustainable choices about what we use, or use less of those materials as well to keep them going longer. And then the balance of both the kind of financial and technical risk of trying to bring in materials from outside the Earth, and maybe even, not to be too science fiction-y about it, but what are the unintended consequences of that too? If they're materials that aren't typically found on our Earth, or different variations of them, are there implications to maybe our wildlife or human life here that we haven't thought of yet? So we're going to need a lot of people to do some work on that, I guess, across kind of geology, physics, and the other kind of earth sciences. I think it'll be another very interesting career topic.
Yeah. Are we okay for questions? Do we have much more time for questions? 10 minutes. Oh, 10 minutes. So we're okay. We're okay. Okay, so that's great. So who's next then? Who do we have? Oh, hi.
Hi, I'm Adrian from Closhnahincha, and my question is for any one of you. Why is so much money being used on the space industry and trying to get people on other planets when there are problems that are yet to be solved on our planet?
Okay, that's a big question. So why are we interested in the space sector? Anybody want to answer that?
Yeah, I mean, it's as was mentioned previously, people maybe tend to think of space as pure exploration and trying to get to other planets, but actually there's a lot more going on in the space sector, and a big one is Earth observation, which is monitoring our planet and understanding how it's changing, and understanding the effects of human activity on our planet in terms of the environmental consequences of industry, etc. So this information is constantly being acquired, and actually more and more information all the time is being acquired in this respect, and being fed back into policy and into planning for the future in terms of how we can ensure that we don't damage our planet too much, so and even recover some of the damage that's been done. So there's a lot of different areas in space technology, and looking at reaching other planets is just one of very many.
Yeah. So I mean, you've got your phone, right? So if we didn't do anything with space, you wouldn't have your phone. You wouldn't have like a lot of the TV stations that we have, and nobody would be able to protect our data if we didn't have satellites. And then on top of that, then there's loads of science. So even just to live on Earth, we kind of rely on space to give us the things that we take for granted nowadays. So, okay, next question. Other question? Where are we? Over here. Okay.
It's Jaden again.
Where are you?
I'm here.
Oh, there.
I'm from St. Mary's,
thank you.
Glasnevin,
Yeah.
and I have two more questions. The first one is, if I remember correctly, it was brought up about trying to be able to grow food on the moon or like on different planets. How do you expect to be able to do that, or like do you have any ideas of how to do it already?
Anybody want to answer? I mean, I've spoken to people about this. If you want me to answer it, okay. So there's an Irish scientist who works at the Astronaut Centre in Cologne, Dr. Aidan Cowley. He was involved in one of our Space Careers Roadshows a few years ago, I think, Stephanie. So he's really interested, and he's leading up research in how we can live long term, on the moon with habitats just for research, and then onwards to Mars. So he's been looking at seeding the regolith, which is the surface soil of the moon, with nutrients so that we can grow tomato plants. And they've successfully managed to grow tomato plants, and there's been other studies like that, and the whole area of astrobiology looks at that too. So it's another whole new field of science and research that we're only just tipping into, and it's a fantastic career for you to consider if you're interested in chemistry or biology or any sort of living system.
I think, Niamh, there's been quite a few experiments around growing food on the International Space Station.
Yeah, of course, yeah.
Which is essentially a huge laboratory floating around in lower Earth orbit. And definitely there's been experiments from what used to be Limerick Institute of Technology. It's now ATU, I think. I can't remember. I get mixed up in them all. But certainly there have been experiments from Limerick on the space station. So there's a number of those experiments around growing different...
Like they've grown lettuce, haven't they, successfully on the space station?
Yeah.
Yeah, so they use hydroponics and different things. So it's a really interesting area. Okay, another 2 or 3.
This fella down the front here has had his hand the whole time.
This person here has had his arm up for a long time.
This question is directed towards Emer. I'm just thinking, if you're creating physical hardware, I guess you could say, which removes sound. So we've had a lot of strives towards much higher tech active noise cancellation, and in the future I think it's going to be much more of a prevalent thing we see in everyday technology. Do you think you will be working with this or going into any industry with this? Because I think it's pretty cool.
Yeah, no, noise cancelling technology has gotten so much better in the time since it was first brought onto the market. Like a lot of things, initially as more of a kind of consumer product, because you can sell your headphones for a really high margin and people aren't too worried about that. There are now some car companies starting to work on being able to noise cancel within the cabin of the car.
I was thinking that.
Yeah, which is really interesting, particularly even, people think electric vehicles are really quiet, and in a lot of ways they're much quieter than typical combustion engines. But now the road noise is actually a really big problem, the noise that the tires make as they rub off the road. And that's very low frequency noise, and that's very difficult to block out with traditional acoustic materials, which is what we don't do. So what I would say is I think really there's going to be a collaboration between both more passive noise control, like what we do, and active, because there's always going to be limitations with active, and just environments that active won't work very well in if they're more open or even larger. But I think the two together are going to really help kind of create a much quieter world and have a lot less noise pollution, which I think is essential. The better technologies are getting, in a lot of ways they're also getting noisier, so we have to be able to counteract that.
Thank you. And one more question, is it, Francis?
So,
one more question. Yes, hello.
So my name is Angelos from St. Vincent's, and I have a question from Days, specifically from InSatX. So a lot of cyber attackers, they like to attack the next big thing. At the moment, that's crypto, because the cybersecurity industry hasn't really caught up to that yet. So being the sort of middleman between this world of space and also of cybersecurity, what do you think, like as we go into the future and as satellite systems become more integrated, as they become more numerous, do you find the possibility of a cyber attack attacking satellites to be possible? At the moment, I don't find it is, because at the moment, satellite systems are just so isolated. But as they become more commercial, do we think that this is a fear that we should have? And at the moment, is this something that we're taking into account as we move into this space age? Thank you.
Great question.
Two answers there. One, you mentioned Bitcoin. They use blockchain. That's a type of security in itself. And a lot of security companies use blockchain as part of their suite of security. Satellites, yes, satellites are fair. Satellites have a hard time because the environment they live in are going to try and thrive in is quite aggressive anyway. Cyber security through RF, which is radio frequency, which is how most satellites actually communicate at the moment. There are concerns about that, and there are militaries who are developing, and some very interesting companies. One, again, in Northern Ireland, that is, they're protecting against that. But what we actually have is a physical threat in satellites, where an actual satellite can attack another satellite. They are in development, and so other satellite manufacturers are developing physical and software ways of protecting themselves. But this is an unfortunate evolution in satellite and how the world and governments react to each other. So yes, it has been addressed.
Thanks, Hugh. Okay, I think that ends our question and answers. What we're going to do now is I'm going to get our panellists to deliberate and think about the best question. I'm so glad I don't have to do that. Before they leave the stage, I'd like to thank them because they are all very busy people, and they've all given you a really good insight into their own businesses and how they're integrating space into their careers every day. So can we thank Des? Thank you very much, Des. Emer, Aubrey, and also Stephanie. So thank you so much. Really, there you go. Look at that. Thank you. It's great to hear. It's great to hear hands-on. It's great to hear about hands-on applications to space, and I hope that you guys can think about a future after hearing their stories. So the four of you go and deliberate, and I'm going to start running the Kahoot. So thank you so much again.
Thanks, Steve.
You're running the Kahoot. Oh yeah. Okay. So myself and Francis. Oh, the evaluation. Okay, first, before we run the Kahoot, we need you to use this QR code for your evaluation. It's really important that we know what you think of today. Really important, because we are always trying to do better. And so run your evaluation. Goodbye, school that has to go. Goodbye, school. Goodbye. Thank you so much. Bye. So for those of you that can stay, so, come here, Francis. So this is Francis. Francis runs everything from Blackrock Castle Observatory. So what do you want us to do with the evaluation? Just tell us.
So this is the follow-up of the evaluation that you completed when you came in. So if you can scan the QR code, it gives you Microsoft Forms, quick responses. We're not asking for you to overthink it.
Just what do you think?
Give us a quick responses. We're asking some of the same questions because we want to see, has being here made a difference to how you think?
Yeah, lovely.
Okay. And then we'll pop up a Kahoot, and so you'll need your phone again for the Kahoot to enter, and you go to kahoot.ie and enter the code.
Thanks.
So has everybody who needs to get this got it? Can I pop up the Kahoot? You can be answering the questions, open up another tab. Brilliant.
Thanks. So we're going to work together. So Francis is in the background now running the Kahoot, and I'm just going to call out the questions. So we'll start that shortly. I hope you've enjoyed today. You know, it's really great to hear from people that are running their own business because they're extremely busy, and it's great that they gave their time to us today. So thanks for that. Now, how are we doing? Are we ready for the Kahoot? No, I'm hearing a few no's, so let's just wait, because I want to make sure you all go. So if you were listening this morning, this should be easy. So every speaker dropped in a piece of information that you may need to know in the Kahoot quiz. Oh, here we go. We're already starting the Kahoot. I'm sorry. All right, so there's the game ping, 668-821. Now, for you to win, do they need to have their school? No, they don't. They don't need to do that anymore, do they? No. Okay. All right. So keep putting in your names. And once everybody's registered, we will start. Oh, here we go. They're all starting to come in now. All right. Okay. $105 people. There's actually 700 of you here today, so there has to be more than that. We'll be closing the Kahoot shortly, so please register if you want to win that prize. Oh, here we go. We're coming in now, thick and fast. Will we start?